Alright, today I'm taking a break from my other projects and I'm gonna do something that always has interested me and something that I'm using every day, and that's AI. I want to see how AI works under the hood, what it is. And I want a guide on it, and I found one, and it's on GitHub, which uh, basically means that we have permission to use this guide, really. So I'm gonna follow this guide, and I'm also gonna of course credit the guide in the video description. But I'm gonna use this guide because I hope, first of all, let me just move it here. It's fairly successful. It has 13,000 stars. It is maybe a bit, I don't want to say old, but considering the pace of AI, maybe it will be a bit outdated. So let's see. I'm gonna start with the first chapter. It says here, week 1, practical introduction to LLMs. Applied LLM foundations, things that I would like to know more of. Real world LLM use cases. Okay, domain and task adaptation models. So this seems like one of these introductory chapters in which they just throw a couple of concepts at you, trying to explain you why this is exactly useful, but doesn't matter. So for this we need to write, and in order to write, of course I need to know how to write, but in order to write, I'm gonna open my tablet right here. So let's start. Applied LLM foundations. So this wouldn't be a guide on LLMs without starting with some history, right? So there's an image here, and I'm gonna open it so maybe all of us can see it. It's this image right here. So it says here, artificial intelligence is a branch of computer science that involves creating machines with human-like thinking and behavior. That's AI. That's the encompassing domain. AI. Machine learning is a subfield of AI that allows computers to learn patterns from data and make predictions without explicit programming. So this is the big guy. This is neural networks are a subset of machine learning, mimic the human brain structure, and are crucial in deep learning algorithms. So this is machine learning. These are the neural networks. I hope I'm gonna have space for all of these here. Deep learning. So what's deep learning? It's effective for complex problem solving as seen in image recognition and language translation technologies. So here we also have deep learning. And then we have genai, which is a subset of deep learning, can create a diverse content based on learned patterns. And then we have large language models, which is a form of genai that specialize in generating human-like text by learning from extensive textual data. So here we have LLMs, and then all the way here, oh, I made a mistake. Here we have genai, and inside here we have LLMs. So genai and large language models have revolutionized the field of artificial intelligence. Okay, because by using those domains, we can allow machines to create content such as text, images, music, audio, and videos. So generative AI models generate new content by learning patterns and relationships from human created datasets. But how does it work? At the core of Gen AI are foundation models, which essentially refer to large AI models capable of multitasking, performing tasks such as summarization, Q&As, and classification out of the box. Okay, so the models such as these or ChatGPT can adapt to specific use cases with minimal training and generate content with minimal example data. Okay, so we can train generative AI. So we can train Gen AI by involving supervised learning, where the model is provided with human-created content and corresponding labels. All right, so Gen AI can learn from this data, and the model becomes more proficient in generating content that is specific to that data. So the things we put in, the model gets better at producing those kinds of things, those kinds of data results. Okay, Gen AI is not a new concept. We have an example of early generative AI, and that's the Markov chain, a statistical model introduced by Russian mathematician Andrei Markov in 1906. Okay, I don't care about this. This is ancient. Okay, so the book now, or the guide, mentions, let me just write it here, GANs, which are generative adversarial networks. And GANs basically means that we have two models, and two models are working together. One is generating output, and the other is discriminating real data from the generated output. Okay. Then we have diffusion models as well. And diffusion contributed to the creation of realistic looking images. All right, and then in 2017, Google introduced something that's known as the transformer architecture, which was beneficial in natural language processing, enabling creation and evolvement of large language models like ChatGPT. All right, so that's about history, I guess. So let's talk about LLMs. So the term large language models refers to the sheer scale of these models, both in terms of the size of their architecture and the vast amount of data they are trained on. I mean, this makes sense because the more data you have, you can understand more complex patterns and relationships. Popular LLMs like GPT-3, I think ChatGPT is now using 4.0. It's 4.0. Okay, so we have popular LLMs like GPT-3, Gemini, Claude, have thousands of billion model parameters, or thousands of billion model parameters. All right, so L, M. This means large data and architecture. Now, language models are algorithms or systems that are trained to understand and generate human-like text. So they learn from a lot of data sets, and they predict what the next word or sequence of words will come. So the large thing actually is helping the language models because the initial, oh, I have some space here, because the initial language models were smaller in scale, and they couldn't, because language is really complex, they couldn't capture language as proficient and as efficient as now. But with these advancements in technology and the availability of massive computing power, we have been able to build larger models. Makes sense. And they have billions of parameters. So here I have an image, again, from the same guide that I'm following. It already seems like it's gonna be amazing. Let me turn this off. Yeah. So this is the rise of AI, large language models. What year was this built? December 23. So the end of 20, let's say 24. It's 1.5 years away from us now. And we have here, I don't know how many. These are the billions of parameters. 175 billion. So these are the old ones. These are the ones before 2020, 2021. Wu Dao 2.0. Interesting. This is Chinese. Gemini is owned by Google. Where's ChatGPT? And so the size is number of parameters. So there's also a live visualization here. So we have the latest ones. So visualization major large language models ranked by performance. So it says here there's 1,760 billion parameters in ChatGPT. Open access. So is this free? Open source. Yeah, it is. With performance comparable to ChatGPT 01. Oh, nice. There's also documentation on this. If I ever find myself bored out of my ass, I think I'm gonna read it. Major LLMs ranked by LM Arena score. AI benchmarking community with over 1 million user votes. So DeepSeek is actually doing quite well here. Interesting. Okay, how do we train LLMs? So I assume training LLMs is a complex process, the book says, the guide says, that involves instructing the model to comprehend and produce human-like text. Here's a simplified breakdown of how LLM training works. Okay, from what I know, from my limited knowledge of AI and machine learning, which I'm doing actually on another series. If you're interested in this, please go to my YouTube channel and look at my machine learning playlist. But basically, what happens is, I assume, let's say we have a robot, a crudely drawn robot. So he is then exposed to a multitude of books, web pages, or articles. This LLMs are trying to predict the next word of or token in a sequence based on the context provided, which seems really simple. Like this, when seems not in order of implementing it, but in order of understanding it on a basic level, so you know how it works. So you are not going blindly into using ChatGPT and thinking, oh wow, wait, is this a human behind this? How is this working? It basically just means, and this paragraph here said it, a lot of textual data, and then the model is trying to predict the next word or token in a sequence based on the context provided. So it learns patterns and relationships within the text data. And relationships. So it learns and then it predicts. So the second point is optimizing model weights. The model comprises different weights associated with its parameters, reflecting the significance of various features. Okay, so we associate a value, right? And a value is the weight value. I learned this the hard way. I always thought what hidden knowledge lies behind the weight, but it's not. It's just a value that you assign to a parameter, and then based on this value, we fine tune the algorithm, and we fine tune the weights to minimize the error rate. Fine tuning parameter values. Okay. LLM performance is influenced by two key factors: the architecture of the model and the dataset, which makes sense. Which makes sense, right? It's the way how the model was implemented, how it was designed, and it depends on how it was designed and implemented. The performance depends on that, and of course on the dataset as well. Oh, the next paragraph is probably answering one of my burning questions. And my burning question is, why can't anyone do this at home? Because here it says training a private LLM demands substantial computational resources and expertise. The duration of the process can range for several days to weeks. Wow. So what they do, they buy cloud-based solutions, they buy high-powered GPUs in order to speed up the process. And after the training, they can be easily customized for various tasks. Yeah, by the way, just recently I had an issue with Google. I think it was the AdSense or something. Is AdSense Google's? It was something related to ads, and basically I didn't know what to do. I had to switch my profile from being a business. I was not a business, I'm an individual who makes videos. So I wanted to do this. I didn't know how. So I Googled a bit. They said, okay, you need to contact their customer support. So I did, and I swear to God, I think I was talking to an AI, but it was so seamless that I almost felt like I was talking to a real person. In the end, he didn't help me though. He didn't help me. I found these settings to change the type of my account in somewhere on the page. So this guy didn't help me, but talking to him was almost talking to a real person. Now, if I was talking to a real person, I apologize. But it had these patterns of speaking. If I'm not answering for I don't know 2-3 minutes, he writes, I'm patiently waiting for your response. He's like nudging you to. It's like a call to action to answer. All right, where have we stopped? There are 3 prevalent learning models. What are those? Zero-shot learning, zero-shot learning. So the base LLMs can handle a wide range of requests without explicit training by using prompts. Through the accuracy of responses might vary. Okay, makes sense, right? You feed it a lot of requests, you have a lot of data, but because you feed it a wide variety of data, it can't create a proper answer to minimize the errors. Then we have few-shot learning. By providing a small number of pertinent training examples, the performance of the base model significantly improves in a specific domain. Makes sense. Makes sense. You feed it something specific. You want to know about, I don't know, foot fungus. So you feed it a lot of data on foot fungus. So it becomes better with these informations. And then we have domain adaptation. Domain adaptation, this extends from few-shot learning. So where practitioners train a base model to adjust its parameters using additional data relevant to the particular application or domain. So this is just theoretical. There's an image here on the use cases. Let me open that one as well. So here are the use cases. So what do we have? Content generation. You provide a prompt, LLM returns coherent and contextually relevant text. That's it. Okay, so where can you use it? Social media management tools, content creation platform, advertisement agencies. These are the real world applications. What else do we have? Language translations. By the way, LLMs are wondrous at translating language. I tried it with Japanese, with German, with Spanish. Really, really, really good. Yeah, translation services, global communication platforms, business applications, really good, really. Text summarization. A lot of college students are doing this. But basically what it means, LLMs are, you provided a book, you provided something lengthy, and you want to pluck some data out of it. You feed it to the LLM, it returns you basically this summary of the most important concepts. Or even if you care about some concepts more than other, you can specify this so LLMs can extract these informations. What else do we have? question answering and chatbots. Yeah, the thing that I talked about. You implement them in your systems, and they have these conversations, almost human-like, almost tree-like. Content moderation on social media platforms, online forums, stuff like that. Information retrieval. What's this? So okay, this is something new. So they can understand user queries and they can retrieve relevant information from datasets. So they build up on search engines, even though Google went to shit lately. So I need to scroll to the second page. I need to open this. It never happened to me before when I was Googling. I would Google something, not a person. A person you get pretty easily. But I Google a question, and then if the AI generated answer isn't enough, I need to scroll. And never before this has it happened to me that I need to scroll past the way where the first results are loaded in this infinite scroll. Now I need to scroll a lot to get the data I want. I hate this. I hated it. So I'm gonna show you another image here. So this is the market. I need to turn this off. So this is the market of generative AI companies. All of these are in this industry, are trying to reach out of AI and generative AI. Wow. Enterprise, consumer, prosumer, ChatGPT, yeah. Virtual avatars, autonomous agents, voice, Figma, image creation, Midjourney. Man, it's hell out there. Okay, so we also now came across LLM challenges. And let me open the tablet again. It's here. Welcome back. So what are the challenges? We have the data challenges. Data challenges, which means that we can have biased data, that we can have limited. Yeah, this makes sense because on what we feed the model is what it produces. So if we have prejudices and if we have biases, it would lead to biased model outputs. Okay, a limited world knowledge and hallucinations. Also makes sense because LLMs can have limited knowledge, and also they can be biased. And also it depends on data. Basically meaning it's influenced by the quality of the data we are training it on. Now, ethical concerns. Now, ethically, what do we have? We have concerns regarding the responsible and ethical use of language models. We have data that might not produce the objective answer because it's fed, because the data that's being used in the model is biased. Then we have copyright issues. Then we have user privacy concerns. Then we have a new type of issue. Technical challenges. We need a lot of computing power to understand and deploy large language model. We can't explain them properly. We can't evaluate them properly. There are difficulties fine-tuning them. There is difficulty, there's some vulnerability to manipulations and stuff like that. And what else do we have? Deployment challenges, and that's it. I don't want to use deployment challenges. I'm gonna stop here. And there are a couple of let me close this. Let me close my tablet. There are a couple of resources that the guide comes with. One of them is from NVIDIA. It says, what is generative AI? Generative AI enables users to quickly generate new content based on a variety of inputs. Inputs and outputs to these models can include text, images, sound, animation, 3D models, or other type of data. How to evaluate Gen AI models? We need quality, diversity, and speed. Speed is really important. I work with ChatGPT often. I don't want to overuse it, but I do use it often. Sometimes it just gets stuck and you get confused, you get angry even. So fast generation, really important. How to develop generative AI models? There are multiple types of generative models. So we have diffusion models or denoising. Diffusion models are generative models that determine vectors in latent space through a two-step process during training. This actually, on a simplistic level, you could teach a child this. You have two algorithms. The forward diffusion adds random noise, and the reverse, let me just increase this a bit, and the reverse reverses the noise. And that's how the data, how we provide and we generate data. So variational autoencoder, no idea what this is. I think I'm gonna skip this. Image from a presentation by Aidan Gomez, one of the 8 co-authors of the 2017 paper that defined transformers. Applications, I don't care about benefits. Okay, let's open a new one. Applications and use cases. Impact architecture and more. Oh, it's a 29-minute read. What do you think? Has any of this been AI generated? Definitely. Okay, these are the applications. I think I know from a general standpoint where I can use generative AI models. I want to see is there something that is more. Wait, chatbots. Chatbots in business settings are commonly built using decision trees, stateful LSTM networks, or advanced architectures like GPT. These LLM applications are often trained on a business historical customer service interactions. Now this is what's gonna destroy certain industries, because if you have been working good, if you have been a good worker, good customer representative, good customer support person, your history is being kept, and now your history of your successes is being fed to this angry machine on fucking human growth hormone and trembolone or whatever. And they can solve these issues. First, they can understand those issues and conceptualize those issues a lot faster than you. And they can solve these issues a lot faster than you. And they can work with more people. They can multitask. It's incredible. It's incredible how we are responsible for the demise of certain professions by being good at them. Actually, this is a good article because Rajiv wrote about algorithms that were used for certain of these use cases. For example, I didn't know that BERT is existing, bidirectional encoder representation from transformers. All right, so these are these are all overviews of how AI is being used. I'm not interested in this right now. What else is there? What else do we have, friend? Another article. Generative AI Sect 2. Oh, this one has these trippy visuals as well. Sequoia. Okay, what is the Sequoia saying? When was this article written? 2023. All right, we have decades of technological progress in order to plant the seeds for Gen AI to rise from the earth and claim the world for itself. It's gonna happen one day. It's gonna happen one day. That's why I always said thank you and please when I'm talking to it. I hope it remembers me one day. ChatGPT's rise was the spark that lit the fuse. Agree. Unleashing a density and fervor of innovation that we have not seen in years. What does fervor mean? I hate Brave browser. A passionate enthusiasm. This excitement was especially visceral in Cerebral Valley, where AI researchers reached rockstar status and hacker houses were filled to the brim each weekend with new autonomous agents and companionship chatbots. Okay. This is also true. Every company wants to double in AI suddenly. Oh, our application for, I don't know, producing rectal cream is suddenly AI powered. What does this mean? I don't know. Does your rectum apply and get more nutrients from the cream? No idea, man. But everyone is suddenly, yeah, AI Salesforce, AI Adobe, AI Instagram. Fuck. So what do we have here? Most probably this publication had some predictions and they got something right, they got something wrong. Yeah, it is, I think. ChatGPT was the fastest application to reach 100 million. What is MAU? Million active users. Organically in just 6 weeks. What the fuck? Interesting. I'm gonna close this now. Now look at this. I'm gonna open some papers. I hope I can understand them. How can I open this guy? So it has been published on 14th of September of 2023. So there's a number of downloads here. Why can't I open it? So show references. Get access. I need to log in. Is there any other article? What else do I have? Summary of ChatGPT. Okay, so this one is unreadable. Summary of ChatGPT related research and perspective towards the future of large language models. Okay, a lot of smart people here. So this is a comprehensive survey of ChatGPT 3.5 and GPT-4 research. When was this written? 2023. All right, so this has already been said in the guide. But yeah, we have the field of natural language processing, which led to the development of powerful language models, including large language models such as ChatGPT. So what is a key milestone of LLM development is InstructGPT, a framework that allows for instruction, fine-tuning of a pre-trained language model based on reinforcement learning from human feedback. So this framework can align with human preferences with human values. Interesting. and ChatGPT is a successor to InstructGPT. And it's used in education, healthcare, blah, 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 all of the other things. Okay, so this is the figure 1. It represents the number of research papers related to ChatGPT published from 2002 to April 2003. Okay, more and more research papers were published on this topic. What else do we have? So this is the word cloud analysis of these papers, and this is the distribution of papers across different fields. Audio and speech processing, computation and language, computer vision, computers and society, machine learning, software engineering. Interesting. So, applications of ChatGPT. Question and answering in the field of education. I mean, this makes sense. I've been using it for education for the last 6 months, definitely, exclusively. All right, so we had some authors that constructed and created some dataset. Can I open this? Man, Brave is so bad. Dataset. So this is the dataset, right? So these authors constructed this GHOSTS natural language dataset, which consists of graduate level math questions. So let me guess. Even before seeing it, it crushed it. It crushed it, right? Which cursor performed the best? In the Olympiad problem-solving dataset, it performed poorly. Only 2 4-point scores, with majority of scores being 2 points. I mean, this makes sense, right? Because it trained it on graduate level math test questions. Most of these questions are just rinse and repeat type of questions. You have a single form of it with multiple variations. So if you feed it enough data, it's gonna understand the questions itself. But once you come to Olympiad problem solving questions, which are, I would assume, more unique than these are, ChatGPT has never come across these kinds of questions, so of course it won't be as good as for these general questions. Oh, let me move back. Although ChatGPT can generally understand math problems, it fails to provide the correct solutions. Okay, in the medical field, ChatGPT question answering capabilities can also be applied to the medical field, such as for answering medical questions from patients or assisting healthcare professionals in diagnosing diseases. All right. It's really interesting how certain research and experiments are done as closely resembling interactions of patients with real doctors. So basically what we have here is that we had an experiment that basically in which ChatGPT was supposed to impersonate a doctor in the same amount of words. It should respond with sounding roughly the same as the doctor, which is really interesting. So the result of experiments showed that the probability of correctly identifying ChatGPT's response was 65.5, while the probability of correctly identifying the doctor's response. So what's this? Two out of 3 people know that something is AI generated, which is actually quite good. I wouldn't have expected this percentage. Yeah, in addition, the experiment found that the patient's response to the trustworthiness of ChatGPT's function was weakly positive, and trust decreased as the complexity of health-related tasks in the question increased. Again, this makes sense. ChatGPT is really good for low-level complex problems. As the complexity increases, as the thought process required to understand something increases, I don't think ChatGPT can hold a candle to a human, but at the same time, this human who knows this is someone who most probably has been in the education system for like 20 years. He's an expert in his area. And having a machine being, I mean, not as close as them, but similar. Oh, that's quite good. In other fields, text classification. Zhang et al. Employed ChatGPT for stance detection. This includes support and oppositions. They use ChatGPT to classify the political stance of tweets in the SEM-eval datasets. So how good did it guess? 68, 58 to 79. I don't understand this. Oh, text generation. What else do we have? Code generation. All right, let me take a look at this. I mean, this makes sense. If ChatGPT generates code that has a properly written prompt and it isn't exhaustively complex, I think it's gonna go pretty well. It's gonna do good. And also it can adapt, it can learn new languages, new frameworks. Yeah, also code explanation. It's really good at explaining code. Now, how complex are we talking about? Because here it says ChatGPT can be used to accomplish some complex programming tasks. How complex are we talking about? Iris, Titanic, Boston Half-Acre. ChatGPT generated correct Python output. Wow. So it can access structured data sets and perform basic software operations. Inference, what else do I have? Data visualizations, I don't care. Quality assessment, human ChatGPT collaboration, medical applications, ethics. I think I'm gonna close it here. I'm gonna end it. I hope you liked this episode. It hasn't been, I haven't been doing the things that I usually do. I might continue. I will continue with generative AI and LLMs because I find them really interesting. Thank you for watching.